What's up, ladies and gentlemen? I'm David Myers, teacher of mathematics at UTC South Durham. We are in a strange time right now, and most of you are sat at home thinking, well, this is all well and good, but what about my math? Perhaps you're in year 11, and you know fine well that you want to do A-level mathematics next year, or a course that relates a lot of the GCSE mathematics, and you need to get that course finished off. Maybe you're a parent sitting at home thinking, I need to make sure that they're focusing on their mathematics, but I haven't looked at GCSE maths in years. I can barely remember indices, let alone trigonometry. If the answer to any of those was yes, or that describes you, then this channel is for you. I'm a maths teacher and I want to share my lessons and my explanations of GCSE mathematics with as many people as possible to make sure that we're all keeping up with the GCSE mathematics content. Before we get started, however, I want to show you the website where you can get a copy of the resources that I'll be using in these slides for yourself. They're all free, they are all A-star quality, and they will be absolutely perfect for you at home if you want a slightly more interactive series of lessons. The website we'll be using for these videos is drfrostmaths.com because it is jam-packed with free resources for absolutely anyone. Whether you're studying GCSE mathematics, maybe you're in Key Stage 2 or 3, even at A-level mathematics and those wishing to study mathematics at university, there are resources for you available on this website. If you're just wishing to practice a single skill, you can type in the name of that skill, say for instance Pythagoras theorem. There's a set of questions that you can try and get instant feedback on, as well as other videos from Dr. Frost himself. In the meantime, what I'm going to be doing is putting the slides on screen with my explanation over the top, in the same way that I would deliver a lesson to every single one of my students. What you can do at home is go through these videos at your own pace. Rewind as and when you need if you didn't quite catch an explanation. We'll go through some trial questions to help you see if you've got it, with an explanation for some of the slightly harder questions that appear. They will then be left on the screen, the main questions, so that you can go through them. Half of the questions will usually be revealed after a few seconds, and all of the questions' answers will be revealed after that, so that you can learn interactively as best as you can at home. The links for all the slides that I use will be left in the descriptions, as well as any other websites that I happen to use as part of the resources. In the meantime, let's do some maths.
So we're going to start with algebraic expressions. Why? Because algebra is one of the single most useful tools in modern day mathematics. In virtually every industry that you can think of, you'll find that high-level algebra has been used somewhere. It is also the subject that most of us in the classroom are absolutely terrified of. So we're going to start with that. We're going to make sure that we can have you feeling confident in algebra. Because if at any point you're not sure what's going on, you can always scroll that video back, watch it again, look at the explanations and the answers and see where things are going wrong. Bit of a history lesson though to begin with. The word algebra actually derives from the Arabic jabara and later on algebra, meaning to reunite, to restore the reunion of broken parts. Fun little fact, the reason that we use the curly X in algebra is because that comes from the Greek word xenos, meaning stranger or unknown. Algebra is designed to restore the unknown value, x. But if I were to think about your age, or my age, or the age of anyone or any pet sat around you, there are lots of things we can do about that. The difference is, for every single person, there's probably a different age there. So how can we do some universal trick with it? Well, actually, we know several things. If we wanted to figure out our age in 4 years' time, regardless of the age, we would add 4. So A, representing any age we can think about, we can add 4 to get the age in 4 years' time. What if I wanted to think about double your age? Well, we could write that as 2 times A. 2A would represent double or twice your age. Again, doesn't matter what the age is, we're doing the same thing with all of it. And regardless of your age, A over 3 would tell us what 1/3 of your age is. One thing I love about that is it represents the absolute power of mathematics. You can put in any number in there. You can put in your age, your younger sibling's age, the age of a Time Lord, and you would still get 1/3 of the age. Mathematics is incredibly powerful because it can represent an infinite number of things algebraically with just one letter. But that's me absolutely nerding out, and I'm not going to apologise for that. Second cool thing about mathematics that most of you don't probably know is that there are actually 2 fundamental branches. The first is what's known as modelling. The second is known as solving. So in your exams you see these weird and wonderful worded questions, and you can't make head nor tail of it. One key skill is informing an algebraic problem. We get rid of the bits and pieces that we're not interested in. We turn it into cold, hard maths that we can then solve. What we'll focus on eventually is how to solve these equations. We'll come back to representing problems algebraically. Again, another nerdy power of maths that I ain't going to apologise for. What we're going to do for now is think about some of the basic things that we can do with these terms. 4a plus 3a. It's tempting to look at that and come up with any array of answers, and it's hard to know which is the right one. Until we say, what if I considered that as apples? Turn it into a sentence. 4 apples plus 3 apples. You can think fairly quickly that that would be 7 apples. Nothing more, nothing less. You can think of it in pretty much the same way down here. Just turn it back into the letters. 3x's plus 7x's. That'd be 10x's. Minus 1x, that'd be 10x's minus 1x, that's 9x's. Not 9. They don't cancel out, by the way. Notice, taking away an x doesn't cancel it out. All we were saying is before I had 10x's, now I've lost one, I'm left with 9x's. And what about down here? 3a plus 4b. Well, we're now dealing with different letters. But again, take it back to the apples thing. Let's chuck in bananas. 3 apples and 4 bananas. I pick up another 3 apples. Well, now we've got 4 apples and 4 bananas. But we lose 2 of the bananas, which means we must be left with 4 apples and 2 bananas. That's it, by the way. You don't need to combine them. Always try and have some little image in your head. If you were tempted to do anything with that, with my 4 apples and 2 bananas, could you say reasonably that the answer is 6ab? Well, no, because there's no such thing as an apple banana. At least not yet, not that I'm aware of. So leave it as 4 apples and 2 bananas. If the logical thing, if the minute anomaly doesn't make sense to you, don't use it. Anomaly is not the word I'm looking for. Analogy. Analogy is what I'm after. English is important, folks. 4 apples and 2 bananas, not 6 apple bananas. Bad analogy, just 4a plus 2b. But that leads us on to something very interesting there. Which things can we add together and which ones can't we add together? On the screen at the minute, there are an absolute jumble of letters that we might be tempted to try and add together. Can we add 2x squared to 9x? Can we add 2x squared y to 4x squared y? Sometimes the answer is yes, sometimes the answer is no. You might be tempted to try and group these together for yourselves, and if you want to, pause the video, have a look at it for yourself, that's absolutely fine. What I'm going to do is show you how they can be grouped together with just a very simple transition. Notice how they've been collected. I'll show you that again. Before, we had a jumble. Now there's some sort of order to it. Again, pause the video and see if you can figure it out for yourself. However, for those of us that just want the answer and want to see what's going on, I'll combine them for you. You'll notice that over here, all I have are x squareds. All of those we could readily add and subtract. Over here I've just got x's. All of those we can readily add and subtract. We cannot add these two groups. These are separate. Just as the x cubes are separate, the y squareds are separate. xy squared sits on its own, but x squared y, they have their own group as well. Why? Because these represent x times y, which is very different from x times y times y. Two different things. That's an easier life for you because it means you don't have to combine them. Basically, what we are saying is that we have a like term if they have the same variables and the same powers. Let's see what that means. If we are looking at x cubed plus x squared plus x, the only like terms in here are the 2x squareds. Because this is an x cubed, there's another power of x. Here there's just an x, there's only one power of x there. So we can add these together to get x cubed plus 2 lots of x squared plus 1x. Down here, we've got a 3x cubed, nothing else like it in there. We've got an x squared y and an x squared y here, so we're going to have to do something with that. And finally, we've got an xy squared. Again, that sits on its own. So what do we do with the x squared y minus the x squared y? In the same way that 5 minus 5 is 0, or a minus a is 0, these two, when they come together, will cancel out to become 0, meaning all that's left is the 3x cubed plus the xy squared. Looking at it down here, let's see if we can apply the same sort of logic. 3x squared not an x squared, minus x squared. So that'd be a 2x squared. 4x plus x, 5x. And a minus 3 sat on its own. 2x squared plus 5x minus 3. 3xy, that's got nothing in common down here. 3y, that's got nothing in common. And the 2 plus the 1, well, that's 3. Meaning we are looking at 3xy plus 3y plus 3. Down here, x squared minus x squared. So 8x squared minus 1x squared is 7x squared. Minus 3x minus 4x, that's minus 7x. Meaning that we have 7x squared minus 7x. What I'm going to do is pause the video for you so you can have a go at solving this algebraic pyramid for yourself. You might want to sketch it down in your books or something like that. Up here's an example of how it works for those who've never seen it. We've got 2b in the left-hand side, a plus b in the right-hand side. So if we added these together, we would get 1a plus 3b in the top. Have a go, see if you can complete these pyramids for yourselves. I've made a timer appear here, and that will count down to how long it is before I'm going to reveal the answers to questions 1 and 2. If you're happy with what we've got, absolutely perfect. Make sure you're double checking it. It's always important to double check just so that you can see if there were any missteps in your logic. If you do have plenty of those, it means there's room for plenty of learning. Don't ever be disheartened by a mistake. Let's have a look at question 3, because some of us might have got a bit confused by that. 10a plus 2b. We know that something was added to that to give 5a plus b. In the same way that you've done subtraction before, do the subtraction here. 10a minus 5a means that there must be 5a left over, aka 5a needs to be in here. And b plus 2b, that's not going to be right. b plus another b will give us the 2b, therefore we need this to be 5a plus b to make sure that they are the same. It's nice and symmetrical so far. What about this 3a? 3a had to have something added to it to get 5a plus b. Well, we need another 2a for sure. We need 2a's to make this a 5a, plus another b. 2a plus b in either side. Down on the bottom level is where things get interesting, because here I've just got myself an a, and I need to add something to get 2a plus b. As in, a plus another a will give me b, plus b, you'll notice, gives us 2a plus b. And over here, well, that's easy enough. We need to add 2a's to get from here to here. But how do I get rid of this plus b? A minus b. Because the 2a and the 1a will give me the 3a, and b take away b, they will cancel each other out, meaning that there's no b's in here as required. And finally, to get from 2a to 2a, we don't need to add anything, but to get from negative b up to positive b, we need to add 2 lots of b. Minus b, 0, 2b, as required. Again, I'm going to pause the video and make a timer appear. If you want to have a go at question 4, go for your life. Otherwise, I'm going to talk about question 4 when we resume. Hopefully I got the timing absolutely spot on. We'll have a quick look at question 4. We need to start in the lower left-hand corner, and we get a minus 5x minus 7y revealed to us. These two we can add together nice and easily. And in the top right, we don't have anything for us just yet, but what we can figure out is this one in the top left to get a minus 3x. We need a positive 3x to cancel that out, to get 0 in the final calculation, and from there we are capable of figuring out the bottom 2. Absolutely spot on if you got that. If you only made it as far as question 2, don't worry about it. You're a bit further on than you were before. If you half understand the answer to question 4, you've made it a bit further. It comes in chunks. You can revisit this video tomorrow. You can revisit it in 30 seconds as you choose. Again, what I'm going to do is say, have a go at this task. I'll put a little timer on to let you know when I'm going to start talking about it. What I will do is set 2 timers now that I think about it. The first one is going to reveal half the answers when it's finished. The second one will reveal all the answers so that you can check the working out for yourself. If you are happy with that, then absolutely well done. If you've got most of it right with one minor error, absolutely spot on, very well done. If you find yourself a little bit confused, reach out to a friend, see if there's anyone who's happy to help you out with it at home. I'm sure there's a way around it, but please don't worry about it. Mistakes happen, that's the way we move on. But speaking of moving on, let's have a look at what else we can do. We've done some addition and some subtraction. That's absolutely grand. What about multiplication? If we turn our attention to x times y, you can see already that could look a little bit confusing. If you're not really paying attention or the printer isn't working properly, that x could very easily be confused for another x. Is it an x? Is it a multiplication? Hard to tell. So to make life a lot easier for ourselves, we just get rid of the multiplication term. We ignore it. X times y we just write as xy. Y times x we also write as xy, because we want it in alphabetical order. X will always be followed by a y, will always be followed by a z if there's one there. A is followed by B, C and D and so on. Always write them in order, there is a very important reason for that. We also put the numbers first if there is one there, so x times 2 will always become 2x. X times x, like 3 times 3 being 3 squared, 5 times 5 being 5 squared, x times x will give us x squared. If we were to put our finger over the y here, we would be looking at x times x, which we already know is x squared. So x times xy becomes x squared y. Similarly, y times xy becomes xy squared. 2x times x, 2x squared. 2xy times 3xy. That's where things get interesting. 2 times 3 gives us 6. X times x is x squared. And y times y is y squared. 6x squared, y squared. Same for the last one. 3 times 3 is 9. There's just the one x in here. That's not multiplied by anything. Y times y gives us y squared. And finally, this z is on its own, which means we are looking at 9y squared. xy squared z, sorry. Have a go at the testing your understanding. I won't leave a timer on the board for this one. I'm just going to let you pause. And now the answers. You'll notice that we've been given a slightly different combination, so you did need to be paying attention here. 3x plus 3x. That's the rules that we spoke about previously. That's a 6x. 3x times 3x, however, that's the 3 times 3 is 9 and the x times x is x squared. Here we need to think about gathering the like terms again, so 9y squared minus y squared and minus 7y plus 4y. Be very careful about adding and subtracting negative numbers. You might want to check that out in another video, if/when I get around to it, or from the plethora of other videos on YouTube. 7ab times b, 7ab squared. 8qr squared times 3qr. 8 times 3 is 24. Q times q is q squared. R squared times r, that will be r cubed. Hopefully you're keeping up with this one so far, folks. Very well done if you are. If not, rewind that and have another look at it. Division. We are simplifying. This is where things can get a little bit trickier. For anyone who wants me to do an in-depth video on simplifying algebraic fractions, let me know in the comments after this and I'll get around to making one of those. But it's the same elegant principle. What can we divide the top and bottom by? In this case it's 3, to give us 2 over 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Down here, 2x divided by 2. Well, 2 of anything, 2 times something divided by itself must be the original. X. Think about it as a half of x times 2. You've got 2 halves to give us a whole. If I took a half of 2 objects, I'd only have one of those objects. Whatever rule makes sense for you at home. 2 over 3 we can't simplify. X squared divided by x. Well, x's. X times x gives us x squared, as from before. Previous slide, I believe. 2 slides ago. X over x, x squared, sorry, divided by x, that's an x. Y divided by y squared, that's going to be 1 over y, giving us x divided by y. So there's more x's on the top here, there's more y's on the bottom there, with a difference of 1 in each case. 5x divided by x, they are going to cancel out, leaving us with just 5. 10 over 15, the x's and x's cancel out. 10 over 15 gives us 2 over 3, so we are now looking at 2y over 3. This one's a little bit trickier, but again, think about your algebraic fractions if you don't know about it already. Divide by 4 here. This will give us 3/4. These x's are both going to cancel out with each other. There's one more y up here, so there's going to be a y on the top. There's one more z on the bottom, so there'll be 1z left on the bottom. 3y over 4z. Again, if anybody wants me to do something on algebraic fractions, that was a whistle-stop tour, please do let me know. I'm going to say test your understanding for this if you're happy. Yes, that one looks terrible. It looks absolutely awful. If you're feeling brave, have a go at it. If not, I will explain to you its relevance later on. Yes, I am a fairly cruel maths teacher. I do make my students do this, partly so they realise that they can do it, as can you at home. This is also there to point out that sometimes there is a really elegant answer in everything. So we should have got 6z over 3 for 2z. 7x squared y squared over xy comes down to 7xy. AC squared divided by 4, and this terrible, awful looking thing that any of us would run away from in fear actually boils down to 5x squared y. One of the reasons that we love algebra, the real world can chuck us some form of variable or equation that looks as cruel as this, that we need to solve to make things more efficient for ourselves. Algebra shows us that sometimes it boils down to something just a little bit more simple. You've already done exercises 1 and 2. I'm going to make my face vanish, but I'm going to do the same thing again. I'll reveal all the answers for exercises 1 and 2 if you want to do those as a little bit of revision. Once the timer counts down, I'll reveal the even answers for questions 3 and 4, and then at the end I'll reveal all the answers so that you can check your working. And that, folks, is it for simplifying algebraic expressions. You have learned how to add terms, collect like terms, subtract them, multiply, and divide them. If you got through a third of that and you knew a bit more than you did, you've done very well. If you got through half of that, you've done incredibly well. If you have tried your absolute hardest, you've scrolled back, you've tried to make sense of it, and you've got a bit more than you did before, you are absolutely awesome. But for algebraic expressions, for now, that's it.
That's it for today, folks. I really hope it's helped you out at home. If it has, please click on the subscribe button. Don't worry about the likes, I'm really not fussed about those. I'm not after YouTube glory or anything like that. I just want to know that you are feeling more confident in maths at home. If there are any topics that you really want me to go through, please just put it in the comments as well. The resources are also in the description below. You can click onto those and follow them through. There's Dr. Frost Maths. There's a link for the UTC South Durham where I work. If there's anything else that you need information on, please get in touch. Otherwise, take care.